Homework 15, Exponential Functions, Video 2, Base E, and Calculator Usage. There's a certain number that is so special it gets its own name. You've seen numbers like this before, like pi. I think most of you have seen the number pi before. It looks like this. If I ask you what it is, you're probably going to tell me 3.14, which is an approximation. But pi actually goes forever and never repeats. And there's a word for numbers that go forever but never repeat. Now the digits repeat, don't get me wrong, there's only 10 digits, so they have to start repeating individually, but there's not a repeating pattern. Like, 1/3 is 0.3 repeating, there is no repeating pattern. A decimal that goes forever and never repeats is called irrational, because it's the opposite of a rational number, which is a ratio of two integers, which as a decimal will always end or always repeat. But numbers that do neither are called irrational. E is another example of an irrational number. It's not as commonly known as pi. If you ask me what it's approximately equal to, I would tell you 2.71828, another 1828, 459045. That's as much of it as I know. Now, you don't have to memorize that. For your purposes, it's about 2.72, but you don't even have to memorize that. Why? Because your calculator, if it's got the right buttons, already knows the value of E. In some calculators, you will see a lowercase e either on a button or above a button, in which case you have to press second or shift or something to access that. But even if your calculator doesn't have just an E somewhere, I bet it has e to the x. And if you can't find it, look above your LN button, because chances are your calculator has an LN button. And if it doesn't, you need one that has an LN button. And above it is e to the x. The short reason is these are inverse functions, but we're not ready to talk about that yet. But your calculator is ready to raise e to a power. So for example, let's say you wanted to figure out what e equals by evaluating e to the first power. It is your responsibility to know how to use your calculator. Now, how you press the buttons depends upon whether you have a calculator that displays the problem or one of them that just shows you the last number that you entered. Now, this calculator won't work. It's a baby calculator, has no LN on it. But if you have a display calculator, such as this TI-30X that actually displays the problems as I type it out at the top, then you pretty much type this in the exact order that you see it. To access this, you have to hit second or shift. So in a calculator, you would hit second, you would press the LN button, because that would bring up the command e to a power, and then you would type 1, and then press equals. Now, there are some calculators that will not display this. If you have a display calculator, it will type that, and it will tell you that it's about this value. But if you only have a one-line calculator, which doesn't display the problem, it only shows you either the last number you entered or the last answer it gave you, you actually have to do this in the reverse order. So if you have a one-line calculator, you would press 1, then you would press second LN, but you wouldn't have to press the equal sign, because in a one-line calculator, when you have a function, an operation that only requires one value, such as squaring or square rooting or e to the x, then it executes it the moment you press it, and it executes that on the number that is currently there, as opposed to a binary operation like addition or subtraction, which requires two numbers. So it's your responsibility to know how to use your LN button on your calculator. If you're not sure, give me a text, give me a call, we'll figure it out. So let's say that you wanted to figure out what e to the third power is. In fact, if you have a calculator with an LN button, I would try doing this right now. Pause the video if you want to. But I'm going to go ahead and press it here. Now, I don't know if you can see my calculator here. I'm sure you can now. But I'm going to press second LN 3, close parentheses. So I'm going to come around the other side of the camera real quick. Okay. So when I pressed it, that's what my calculator is showing. Now, more sophisticated calculators will actually put the exponent up in the sky like it's doing right there. So whether your calculator shows you something that looks like this or something that looks like this is irrelevant. Come on, focus. There we go. It should give you the same answer. So I'm going to press equals. In this calculator, it is equals, and show you the answer that I got. So did you get 20.08553692 or something reasonably close to that? If you did, then you used your calculator correctly. If you didn't, then you did not use your calculator correctly and you need some assistance. Let's round this to 3 decimal places, 20.086. So it's your responsibility to know how to use your calculator. Now you can still use it to do other exponential problems, such as 3 to the negative 1.2 power. That one's not that hard to figure out. By now you've probably used your exponent button, which either looks like y to the x, x to the y, or a caret symbol that looks like that, if you have a graphing calculator, a TI. But again, it's your responsibility to know how to use your calculator. So try putting in 3 to the negative 1.2. And while you're doing that, I am going to put in 3 to the negative 1.2 here, and we'll see what happens. Okay, so 3. My exponent button is over here by my thumb, exponent. Negative is down by the, oh, by the way, if you don't know the difference between your negative button and your subtraction button, you need to learn the difference because they're not the same. A negative only has one number to the right of it. A subtraction requires numbers on both sides of it. So back to the problem, 3 to the negative 1.2, and then just press equals. Now, are you surprised that you got a number less than 1? Well, there's a reason why you got a number less than 1, but we'll see why in the next video.